Welcome to my presentation. My title is Forecasting Neural Network Based Fuzzy Time Series. I'm from Anadolu University, Department of Statistics. I will start with my presentation. Firstly, introduction, and then fuzzy time series, then neural network based fuzzy time series. Finally, empirical analysis and conclusion. Fuzzy set theory was introduced by Zadeh in 1965. Then the concept of fuzzy time series was introduced by Song and Chisoms. Since then, many fuzzy time series models have been proposed, such as first order models, Chen, Huang, Sullivan-Wood, high order models, Chen, Huang, Yu and Huang, hybrid models, Huang, Tseng, Tzeng, seasonal models, Chang, Song, bivariate models, Husu, Tse, Hu, Yu and Huang, and finally multivariate models, Giuliani, Burnley, Chang, Chen, Wang and Huang. Conventional time series refer to real numbers, but fuzzy time series are struck by fuzzy sets. Song and Chisom first proposed the definitions of fuzzy time series. Some general definitions of fuzzy time series are given as follows. Definition 1. A fuzzy set is a class of objects with a continuum of grade of membership. Let U be the universe of discourse, where U starts with U1, ends with UN, and UI are possible linguistic values of U. Then a fuzzy set of linguistic variables AI of U is defined by equation 1. Here, mu AI is the membership function of the fuzzy set AI. UK is an element of fuzzy set AI, and mu AI UK is the degree of belongingness of UK to AI. Definition 2. Yt is a subset of real numbers. Let Yt be the universe of discourse defined by the fuzzy set Fit. If Ft consists of Fit, Ft is defined as a fuzzy time series on Yt. Definition 3. If there exists a fuzzy relationship Rt-1t such that Ft equals to Ft-1 multiplied by Rt-1t, where multiply by is an operator, then Ft is said to be caused by Ft-1. The relationship between Ft and Ft-1 can be denoted by equation 2. Definition 4. Suppose Ft-1 equals to AI and Ft equals to Aj. A fuzzy logical relationship is defined as equation 3, where AI is named as left hand side of the fuzzy logical relationship and Aj the right hand side. We use the following steps, which are based on Yu and Huang's method, in problem solution. First step, defining and partitioning universe of discourse. Second, fuzzification. Third, training and forecasting. Fourth, defuzzification. And finally, performance evaluation. Neural network based fuzzy time series. This new algorithm for neural network based fuzzy time series forecasting method based on Yu and Huang's algorithm, but has some changes, modifications and is summarized as follows. First, defining and partitioning universe of discourse. This method forecasts the differences between every two consecutive observations at t and t-1 instead of using observations directly. We can see in equation 1. Here, observation t and observation t-1 are two consecutive observations at t and t-1. The differences may turn out to be negative. To ensure that all the universe of discourse are positive, different positive constants are added to the differences for different part of the data. For equation 2. For each part of the data, the minimum and maximum of all differences, dmin and dmax, are obtained. We can see in equation 3. The universe of discourse U can be defined as dmin minus d1, dmax plus d2, where d1 and d2 are two proper positive numbers. Suppose the length of interval is set to L, then U is separated into equal intervals and they are named from U1 to UK, where k is the number of intervals. UI can be shown as equation 4. Its corresponding midpoint is equation 5. Define the linguistic values of the fuzzy sets. Let A1, A2, A3 and etc. be linguistic values and label all the fuzzy sets by possible linguistic values U1, U2, U3 and etc. In this step, we use Huang's approach for determining the length of intervals, which are called distribution base length. It is calculated according to distribution of the first differences of data. Its algorithm is clearly summarized as below. First step, calculate all the absolute differences between AI plus 1 and AI as the first differences and average of the first differences. Second step, according to average, determine the base for length of intervals by following table 1. Third step, plot the cumulative distribution of the first differences. The base determined in step 2 is used as interval. And final step, according to base determined in step 2, choose as the length of intervals the largest length that is smaller than at least half the first differences. Second, fuzzification. Next, the apostrophe t-1t can be fuzzified into a set of degrees of membership vt-1t. vt-1t is shown in equation 6. Here, mu is the membership function which is defined before. Third, training and forecasting. To improve forecasting results, this method uses all the degrees of membership to establish fuzzy relationships. Two consecutive V's can be used to establish a fuzzy relationship. This method then applies multilayer perceptron and radial basis function neural networks to establish or train the fuzzy relationships. It has one input layer, one or more hidden layers, and one output layer. The numbers of input and output nodes are equal to the numbers of degrees membership in vt-1t. The number of hidden nodes is determined by neural network's performance by using Statistica 7 software. With t-1t, it can be proceed to forecast vt t plus 1 by means of the trained neural network. If the in-sample observations are used, the results are referred to as those of the in-sample estimation. If out-of-sample observations are used, the results are referred to as those of out-of-sample forecasting. Fourth, defalsification. Weighted averages is applied to specify the degrees of membership. In equation 8, Fd t minus t is the forecasted differences between t minus 1 and t. Mu k t minus 1 t represents the forecasted degrees of membership, and mu k denotes the corresponding midpoints of the interval mu k t minus 1 t. Once the forecasted differences between t minus 1 and t is obtained, the forecast for t can be calculated as follows in equation 9 and in equation 10. Fifth, performance evaluation. For performance evaluation, the mean square error, mean absolute error, mean absolute percentage error, and root mean square error are calculated as follows. To demonstrate of model of explained method, we use the enrollment data of University of Alabama, which is shown in table 2. This data can be sufficient to highlight the methodology's efficiency because many important studies were applied a field observation for fuzzy time series forecasting, and we used this time series to compare the results easily with other methods proposed in the literature. We applied the proposed method with step by step. Mean square error values of other proposed methods available in the literature and MSE or mean square error value of our proposed method are also given for comparison purpose in table 3. The result of our proposed method has the third smallest MSE value, so we can say that this proposed method outperforms the other methods for forecasting fuzzy time series according to table 3. To demonstrate of model of explained method, we secondly use a large dataset of Istanbul Stock Exchange National 100 Index weekly close price. We applied the proposed method with step by step. We selected the data from January to October for in-sample training and November to December for out-of-sample forecasting for each year, and we calculated average of all years for root mean square error instead of using mean square error because of big values. Neural network based fuzzy time series with our proposed method for giving artificial neural network architectures and with Yu and Huang's method are used to analyze for this dataset. Then root mean square error is calculated respectively for each model. The best ones for each model according to root mean square error values are shown in table 4. Generalized regression neural network, multilayer perceptron, and radial basis function neural network are used to analyze for this dataset. Then root mean square error is calculated respectively for each model. The best ones for each model according to root mean square error values are shown in table 5. We can summarize the results shortly as follows. This study applied a neural network based fuzzy time series model, which is different from previous studies because of using various degrees of membership with neural networks. So by training and forecasting, more information was considered. The length of intervals by using a well-known method, which is called distribution based length approach, is used instead of based on other studies. We used various numbers of hidden nodes. The ratio was 80%, 20% for first dataset, 83%, 70% for second dataset. We applied the base 3 networks, which are called MLP, RBF, and GRNN. These are my some references. Thank you for your attention.